Today we're going to be talking about Rolle's theorem and the mean value theorem. So Rolle's theorem is the idea of let f be a continuous on the closed interval and differentiable on the open interval. And if f of a equals f of b, there must be a number c such that f prime of c equals 0. So the idea behind that is this. We have some graph. And on my graph, I have some function. I'm going to do a parabola because that's the easiest for me to draw right now. I don't know why my drawing is real weird. I think it's because that stuff is there. Okay, so I have f of a equals f of b. So I have a horizontal tangent line. We know a horizontal tangent line has a slope of 0. That happens somewhere in between. Not necessarily the middle. I know it kind of looks like the middle. And because of the symmetry with parabolas, yes, it will happen in the middle. But it's not always in the middle. So our first example. Find the two x-intercepts and show that f prime of x equals 0 at some point between the two x-intercepts. Okay, so I find my two x-intercepts. So x equals -4 and 2. And since f of -4 equals 0, which equals f of 2. Okay, so now I find f prime of x. The derivative of that is 2x plus 2. I need to show that this equals 0 sometime in between there. That happens at x equals -1. Okay, so because, and this is key, because f of x is continuous and differentiable, there must be some value where f prime of that value equals 0. And in that case, our c is equal to a -1. Our second example, find out values on the interval where f prime of 0 equals 0. Okay, so again, f of x is a continuous and differentiable. Can I fit it in? Oh, I didn't fit it in. Function -3 to 3. F of -3 equals 0, which equals f of 3. Sorry, for some reason, I don't know why it's writing so weird. Therefore, by Rolle's theorem, there must be a value where f prime of that value equals 0. So let's find that. f prime of x is equal to 4x cubed minus 16x. If I factor that and set that equal to 0, we get this. So on my interval from -3 to 3, my values are 0 and plus or minus 2. That's kind of funny. In my notes, I forgot about the 0. Okay. Key things that you want to keep in mind here. You need to state that we are continuous, we are differentiable, and this. Those are the conditions to be true in order for us to use Rolle's theorem. And then I say, therefore, by Rolle's theorem, we must have a value. And then I find the value. College Board is really picky when you're utilizing this theorem. So you want to make sure that you state what the conditions you need in order to use the theorem. This is one of those theorems where we need to state the conditions to be true before I can use the theorem. Kind of like intermediate value theorem. You had to state that we were continuous first. If you didn't get full credit, okay? Now, quite honestly, Rolle's theorem is not on the AP exam. But what is on the AP exam is our mean value theorem. So I have the mean value theorem for derivatives. If f of x is continuous on the closed interval and differentiable at every other point in the interior, there must be at least one value such that my derivative equals the secant line. What that means is that means the derivative at some point equals the secant line. Keep that in mind. Okay, derivative equals secant line. So I have here my secant line. What I did before I made the video is I cut and pasted and made another line. Let's see if I can find my tangent line. Looks like it happens about right there. And again, it's not always at the middle. So that's where my C is, where my tangent line is parallel to my secant line. And yes, I understand that if I go up here, those match up to one another because that was my secant line. So now I have my tangent line. Around C, that's technically a tangent line, intersects at one point. Okay? It kind of looks like there's a little tangent line happening up there too, though. All right. Next example. Verify the hypothesis of the mean value theorem. If it does, find the values of C on the interval that satisfy the condition. So I am continuous. So that's that hypothesis part. The hypothesis of the mean value theorem. F of x is continuous and differentiable on our interval. I'm going to use parentheses because continuity is inclusive, differentiability is in parentheses. I should probably break those out. I'm not going to. Okay. From here, I should say, so the mean value theorem, this is the one that's on the AP, and that's an abbreviation, applies. So I find, I'll do my algebra over here. F of -5, where'd my cursor go? There he is. -5 equals 0. So, and f of 3 equals 4. So I find my 3 minus, if I could find my slope right. See, this is the problem. What I'm trying to do is I'm trying to do this in my lunch break. And I'm stressing to get through it. I shouldn't be stressing to get through it. So what I need is I need to set my derivative. So f prime of x, which is 1/2 25 minus x squared to the -1/2 times by a -2x. I set that derivative equal to this. equal to my slope of my secant line, I should say. So I have a negative x on top. I have the square root of 25 minus x squared on the bottom. I cross multiply. And then I'm going to square both sides. So I have 25 minus x squared equals a 4x. I'm going to set this equal to 0. And I'm going to factor. I just realized I made a mistake. This should be 4x squared. So I'm going to erase this a little bit and get me my right answers. So I'm going to add an x squared over. So x equals plus or minus root 5. Haha, there we go. If you do your algebra right, my calculus teacher always used to say it's the algebra that kills me. Mean value theorem applies. And the value, so that's verifying the hypothesis, I should say. And then I don't need to write any more. I showed my work, and those are my values. Now example 4. And this is one of my favorite applications of the mean value theorem. We use the mean value theorem a lot in different applications. So an automobile travels 4 miles along a straight road in 5 minutes. Show that the speedometer read exactly 48 miles per hour at least once during the trip. Okay, so my average speed is 4 miles over 5 minutes. But I need to write that in miles per hour, so I'm going to multiply by 60 minutes in 1 hour, and that gets me 48 miles per hour. Let's see if I can do this. Okay, it might be more helpful if I actually write this out. Okay, so since, let's see if since speed is a continuous and differentiable function, the mean value theorem applies. I don't like that it capitalized that. It's because I pressed enter. Applies. The average speed of the car, because I don't want to spell it automobile, car was 48 miles per hour. This means the instantaneous speed, and yes, I spelled instantaneous wrong. I struggle with that word. Must have been 48 miles per hour at least once during the trip. Okay, let's correct my spelling. Oh, didn't really like it. This is a fun video. Instantaneous. Let's see, let's go down here, see if it likes it now. Oh, there we go. Okay, so, oh, no, it doesn't like it. I'm gonna leave it. I can't move on. Well, I have to move on, I'll say. So it will live in infamy to be incorrect. So since speed is continuous and differentiable, You need those pieces to be able to use the mean value theorem. So those are my hypothesis. Those are the conditions to be true. Then I state by the mean value theorem. I missed my by. By the mean value theorem, or you could say by the mean value theorem, or the mean value theorem applies. You need to state something about your average speed and the instantaneous speed. The word Mrs. Marnell can't spell. Must have been 48 miles. Okay? So that is the mean value theorem and Rolle's theorem.